Welcome to In 5 Minutes. In this video clip, we will discuss modulation index of FM and various factors that affect the modulation index. To discuss this, we will start with the expression of FM, which goes something like this. We see cos, we have omega ct, omega c is 2 pi fc plus 2 pi kf integration of m of tau d tau. This is the general expression of FM that we consider. To define modulation index for single sinusoidal signal, we take m of t as Vm cos omega mt. So this is my modulating signal. So my FM equation will now become Vc cos omega ct plus 2 pi kf is a constant. Kf is called frequency sensitivity of FM. Let us integrate the modulating signal. So integration of Vm cos omega mt will be nothing but Vm will remain outside. Integration of cos will be sine omega mt. And whenever you integrate any function, you divide by the coefficient of t. So we divide by omega m. So this will further become Vc cos of omega ct plus omega m will be 2 pi fm. 2 pi will cancel out. So we will have kf Vm upon fm into sine omega mt. And if you remember, we later on make substitution for this kf Vm upon fm, and this we substitute as mu f, which is the modulation index. So we finally get the FM expression in the form of modulation index. It becomes Vc cos of omega ct plus mu f sine omega mt. So where mu f is the modulation index and it is nothing but kf Vm upon fm. What are the factors that affect the modulation index? The very first factor that affects is kf. Kf is called frequency sensitivity of FM process, and if you remember, in one of the video clips we have discussed kf in detail. Kf is further defined as delta f by Vm. So frequency sensitivity depends upon delta f, and delta f is nothing but frequency deviation. So we can say that the first factor that affects the modulation index is kf, which is frequency sensitivity, which further depends upon frequency deviation. So you can now see that if I want large frequency deviation, if the delta f value has to be increased, this indicates that frequency sensitivity will also increase, and this further indicates that modulation index mu f will also be large. And this is the case in wideband FM. In wideband FM, delta f is very large, and hence modulation index is generally a large value greater than 1. But in case of narrowband FM, we keep the value of delta f small, and hence mu f also remains small. So very first factor that affects mu f is nothing but frequency deviation. The second factor on which mu f depends upon is called Vm. Vm is nothing but peak modulating signal amplitude. As we can see that mu f is directly proportional to Vm. So if Vm increases, if the modulating signal amplitude increases, then modulation index will also increase. And the third factor on which mu f depends upon is Fm. Fm is nothing but modulating signal frequency. And you can see that mu f is inversely proportional to modulating signal frequency. And hence if modulating signal frequency increases, then mu f will decrease. Now this is something very interesting, because if you remember, in case of AM, the modulation index was Vm by Vc, and hence it does not depend upon the modulating signal frequency. So given any value of FM, the modulation index was constant. But in case of frequency modulation, you can see that for smaller modulating frequencies, mu f will be large, but for greater modulating frequencies, mu f will be small values. And exactly for this reason, when we talk about the effect of noise on FM signal, the effect of noise will increase if the modulation index is decreasing, and hence the effect of noise will increase for increased modulating frequencies. So for high modulating frequencies, the effect of noise is more. For low modulating frequencies, the modulation index will be large, and hence effect of noise will be less. And hence when we define SNR in FM signal, it is not constant throughout the modulating frequencies. If the modulating frequency increases, the SNR will decrease. And hence we go through a process called pre-emphasis, in which we amplify the high frequencies in terms of their amplitude so that we can increase the SNR for high frequencies. And then we carry out the opposite process of de-emphasis on the receiver side. So in a summary, modulation index in FM depends upon three factors: frequency sensitivity, which in turns depends upon frequency deviation, peak modulating signal amplitude, and modulating signal frequency.